In today's video, we will be finishing off the substation details, including the wiring. We'll then move on to test fitting the high voltage towers that feed the substation. We'll also take a look at installing a missing dwarf signal. It's been missing for a number of years. And we'll move on to talking about rolling stock, some new bulkhead flat cars, and some sheet steel loads for those cars. This is where we left off our last video. We had installed all the components, but we hadn't yet connected them to each other. With a great deal of patience and time, you can connect them up with wires. You have to use a fine gauge wire, and as I said, you need a lot of patience. You're not going to get it on the first try, the second try, and maybe even not the third try. This is all you get in terms of instructions with the Walters kit, but it's a fairly logical sequence of what gets connected to what, and we'll walk you through it. These are the tools you'll need: a pair of snippers, a pair of needle nose pliers, super glue, and any fine gauge black wire will do. I worked my way from left to right on the project, starting with the aluminum bus rods connecting to the left side of the transformer. I cut 3 pieces of wire about 3/4 of an inch long and bent the top 1/4 inch or so to a 90-degree angle. This is where patience and a very steady hand comes in, because you can only use a tiny dab of the glue on the tips of the rods and bushings. Try as hard as you can to make them an end-to-end fitting rather than an overlapping joint. Repeat the same process with slightly longer wires to connect the main bushings of the transformer to the rods on the right. And we repeat the same process again, only with even longer wires. These are about 2 inches to connect the circuit breakers. And finally, the longest wires, they're about 3 inches long, connect the circuit breaker to the elevated structure. This is where the wires coming down from the transmission towers will connect to the substation. And here we see our crew getting ready to make those final connections. Most transmission substations have some form of office or tool shed for workers to use locally, and this little kit looks like it would fit perfectly. I'll say this at the start here, this is not a very detailed kit. It wasn't put together by Walters as an office. They used parts from other kits. The container is from another kit, and the windows aren't actually windows. You have to paint them black and just try and highlight the moldings to make it look like a window. With that said, it'll do fine as a background kit hiding inside the substation. I used a permanent marker to give the window a glossy black finish to look like glass, and followed up then using micro brushes to paint the edges and the moldings white. You could try doing it the other way around, painting it all white and then coming back and trying to paint the flat surfaces in between the moldings black, but I felt that would be a harder exercise. With the windows done, I painted the door and frame matching white and found an offbeat color for the office container itself. This is how you know this container wasn't meant for an office kit. You have to physically remove portions of the ribs for these windows to rest in place. Using the right tool helps. When all is said and done, the kit forks out just fine, kind of tucked away in the backside of the substation area, and you're looking through the substation at it, so you have somewhat of an obscured view. It also helps to add a splash of color in a sea of gray. The Walters transmission tower kit comes with many parts, enough to make several different variants of these transmission towers. Unfortunately, the tower cores, the poles, are only 9.5 inches long, which translates to less than 70 feet in HO scale. Based on my research, this suggests that these poles would not be carrying much more than 100,000 volts. So it's not really a high tension, it's a medium tension pole system. It also means that these poles aren't tall enough to carry wires over taller buildings or taller trees, in fact. They're probably best suited to run along a low-level highway or suburban main road rather than some of the ones you see along railway tracks that are well over 100 feet high, sometimes 130 feet high. That said, I may still be able to make use of these poles if I run the tower line along the tracks and not try and climb over buildings and tall forests. There's one other quirk about this kit. They do give you a wide pole, which is meant for 90-degree bends in the transmission line. The odd thing is that there's only 3 wires in and 3 wires out, which means if you're running 6 wires on the other 5 poles in the kit, you need a second pole like this to move all 6 wires. So this only really works to make a bend on 1/2 of the transmission lines that are on the 6-wire poles. With this in mind, let's take a look at some of the locations where we might plant these poles, at least for now, until something better comes along. Here's a location where we can have the pole line start or end. It's running off on the edge of the layout. Not a lot of action here that would require operators to be reaching in through or over the wires. Another good location, both for access for maintenance and, again, location where nothing will be in the way for operators reaching in, is right at the junction and roadway crossing. My only concern here is whether the wires would end up being too close to the roof of the tower. And here's where the pole serving the substation will be located. The wires would continue to the left to the other 2 poles, and another set of wires would come down and connect to the substation. All of these pole locations are spaced roughly 42 to 45 inches apart, which works out to about 300 scale feet. Not bad. Typically these poles are spaced around 500 feet, but 300 is a good selective compression number to use. Here's a neat idea to have the pole up on the hillside in the corner of the layout. Not a bad idea, but again, it's just barely clearing the tops of the trees. If you look closely at the holes in the pole, you could see the lower wires might actually be interfering with the treetops. And here's a spot a little bit to the right along the wall to avoid having to try and plant the pole at the top of the hillside and worry about crossing the trees. This kind of looks like a forced perspective that the pole is actually further than it is, and it might work better, and it would certainly clear the tops of the trees. And being right against the wall, it kind of disappears into the background and gives you the impression it's going through the wall. This is a location on the other side of the layout, just to give you a feel for how tall these poles are relative to, let's say, a 2-story warehouse. If you look closely at the holes in the pole, you can see that the lowest set of wires would barely clear the top or roof of the building. And it's only a 2- to 3-story building, so not really very tall. There is one alternative that can be used to make at least one of the poles much taller, and that is to mount the regular pole on top of the wider pole that's meant for the 90-degree bends. They kind of end at the same diameter, so you can cut the part of one off and glue it to the top of the other in a fairly seamless joint and have the pole as long as you'd like. Unfortunately, you can only do this with one pole, unless you want to go out and buy another kit just to double up on the height of the poles, or somehow make a mold from this one piece, and then start making multiple bases for your other poles. I'm going to give this some more thought, and we'll report back in a future video. Eastbound interchange movements access the Conrail main line through a long crossover at the east interlocking. This crossover connects to the Quebec and New England arrival-departure track in the interchange yard. Movements through this crossover are governed by the Conrail dispatcher, and as such, this turnout is signalized. This eastbound Dwarf signal is just one of those things that I just never got around to until now. I'm using the Tomar Industries double-headed Dwarf searchlight style signal. Everything you need for fully operational signals is included in the package. My immediate concern is the aesthetics of having a signal, not necessarily having operational signals. I painted the signal lens hoods black using acrylic paint. Then I drilled a 3 32" hole about an inch beyond the turnout switch points, and then fed the wires underneath the layout. I left them coiled up for now, just like all my other signal wires. Not sure when I'll get around to connecting them. For many years now, I've been slowly purging my roster of original Athearn and Roundhouse cars, replacing them with better quality or more highly detailed versions. Recently, both Scale Trains and Rapido have released prototypical 66-foot inside length bulkhead flat cars. You can really see the difference when you put them side by side. The old Roundhouse cars are 60 feet over the couplers compared to 77 feet for the Scale Trains car. They also use real wood in the floor and on the bulkheads. The underframe is a metal casting, so I'll also expect these to ride a whole lot better than the Roundhouse cars. The Scale Trains cars come with their own proprietary metal coupler. It is a spring-loaded knuckle, but it doesn't have a glad hand for magnetic delayed uncoupling. Scale Trains use their own proprietary centering spring in a very narrow coupler box, so I replaced them with KD's semi-scale long shank whisker couplers. Here's a side-by-side comparison of the Rapido cars with the Roundhouse cars. Same comments as the Scale Trains cars, except I didn't have to change the couplers. With my bulkhead flat cars now expected to ride a whole lot better, especially when empty, I turned my thoughts to how do I keep my regular 60-foot Roundhouse flat cars from stringlining, especially when they're near the front of the train. Well, a long time ago, I purchased 3 kits from Adair shops. They were for plate steel loads. These are wonderful kits. Sadly, they're no longer in business as the owner has recently passed away. These are very simple and straightforward kits to build. They include 5 sheets of steel, lightly coated on one side to simulate steel coloring, and they include various sizes of lumber for both the main support underneath the first plate and for all the individual pieces between each sheet. The large cross-section lumber is glued longitudinally underneath the first plate, and the smaller cross-section lumber is glued perpendicular to the plates. I was deliberately not too careful with how I place the lumber between each of the sheets, so it would give it that random kind of look. When I opened up the second and third kits, I realized that the manufacturer had randomly included different sizes of lumber in each package. The first kit had 3" by 3" lumber for placement between the sheets, And the second and third kits had 6" by 6" lumber, and the ones with the larger lumber had fewer pieces. So it added some unexpected but welcome variation between the loads. Here's a look at the 3 loads sitting on 3 roundhouse flat cars. This is just a test fit. Now that I have the higher quality bulkhead flats that can run empty, these loads will be placed on the remaining 60-foot roundhouse regular flat cars. The roundhouse bulkhead flat cars will be retired. What's next is finishing off the very last bare piece of plywood on the layout. This is where the substation was originally going to be placed, but we are now going to put a vehicle maintenance garage here. This will give us a chance to showcase some of our company vehicles. All this and more in our next video. As always, thank you for watching. If you enjoy layout improvement videos, here are a few others that you may find interesting. If you're not already a subscriber, you can click on the logo on the top right-hand corner of your screen.